Thanks, Shannon. Hello, everyone, and welcome. My name is Megan Jacobs, and I'm the webinar coordinator here at Data Blueprint. We are so excited you all found the time to join us for today's webinar on Unlocking Business Value Through Data Modeling and Data Architecture, Part 2. As always, a big thank you goes out to Shannon Kemp and Dataversity for hosting us. We get started in just a few moments after introduce your speaker and also let you know about some housekeeping items. We are planning 1 hour for the presentation, followed by a 30-minute Q&A session. We'll try to answer as many questions as time allows at the end, but feel free to submit them as they come up throughout the session. To answer the top 2 of your most commonly asked questions, yes, you will receive an email with links to download today's materials and any other information you request during the session within the next 2 business days. You can find us on Twitter and Facebook. We have set up the hashtag DataEd on Twitter. So if you're logged on, feel free to use it in your tweets and submit your questions and comments that way. And we'll keep an eye on the Twitter feed and we'll include answers to these questions in our Q&A towards the end as well. Also, we have a special webinar coming up next month. Join Peter Aiken and Micheline Casey for an interactive discussion on the role of Chief Data Officer of the top data job. Attendees will be presented with ideas and alternative ways not only on how to think about the role, but also how to plan and establish a CDO or TDJ position at the organization. Now let me introduce you to our speaker. Dr. Peter Aiken is an internationally recognized thought leader in the data management field. Many of you already know him and have seen him at conferences nationally and worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions. Peter is also the founding director of Data Blueprint. Peter has written 7 books and dozens of articles. He has experience with more than 500 data management practices in 20 countries and consistently named as one of the top 10 data management experts in the world. Peter has spent multi-year immersions with organizations as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. He is highly desired at conferences and workshops and always traveling to numerous speaking engagements and projects. Peter, where are you today?
So thanks, Megan. I'm on the campus of George Mason University in Fairfax, Virginia. It's my alma mater, and I happen to be up here working with my fellow research scientist, Randy Howard, who is running a big data class up here. So I figured as long as we were doing it, we'd spend the day together and have some fun. So we've actually got a live audience in the room today, too. They had their arms twisted to come on and get a little extra credit for class. Now they're interested in big data, and this is a big component of it. So really looking forward to the session here today. As both Shannon and Megan mentioned, this is part 2 of a 2-parter that we put together for this year. The first one concentrated on modeling and hopefully got you some thinking about some other ways of using data modeling techniques in here. As always, these are brought to you by the VCU School of Business and Data Blueprint. And most people, when they look at these big pictures that we come up with, they're sort of saying, all right, what do I do with that? Because it's kind of a scary diagram. So we'll take it in bits and pieces, but this is the word cloud of what we're going to do. So if you're more visually oriented, that's it. And if you want to do a standard linear approach, we're going to talk about what are we doing in data management. We'll review part 1 very, very briefly. I'll get into a definition of data and information architecture. We'll talk about the whys of data and information architecture. And then I'll go straight to an engineering example that shows how we have to leverage these concepts and finish up with some examples at the end. And we had some great discussion last time. I'm looking forward to it as well. We've also, as always, got some polling questions where we can ask you guys some questions because we use this to capture some real-time sentiment analysis on what's going on here. I'm sorry, this is the place we always start, which is the 5 integrated data management practices. Of course, everybody looks at this and it's after lunch and your eyes are spinning and it's really confusing. So we'll show you the Dilbert pointy-haired boss version of it, the simple version. Data management consists of 5 integrated practice areas. The first one is data program coordination, and we're trying to manage the data coherently. The second one is that we're trying to share data across organizational boundaries, whether we're moving from program to program, from part of the organization, department of the organization to another department, or whether we're exchanging data between our organization and our partner organizations. A lot of data transfer happens, and not all of it's managed very, very well, and certainly most of it is not done as efficiently and effectively as it could be. Let's not even talk about security because that's another whole piece that gets into it as well. If we don't make data personal, then it's everybody else's responsibility. So this means putting somebody's name on something and saying, Peter, your next raise will depend on you raising the quality of this data in measurable and demonstrable ways. If you don't have that happen, generally nothing happens in the organization because it's everybody or everybody else's responsibility. Again, we need to deliver data development systems. The idea here is that in the past, this has always meant to people building us some more relational databases. Nowadays, we know there's lots of things with virtualization, XML, and portals that we can pull into play that are alternatives to this. And just even the relational model we know is subject to some limitations. This is one of the main reasons we're looking at these big data technologies, because these now allow us to do some trade-offs in terms of what goes on. And we'll do some big data stuff later in the year on this. And finally, our fifth one is maintaining data availability, which is the idea of making sure that you have business continuity, disaster planning, and recovery, much less tuning your various database types in there. You can't just simply put them up. They're not like cars. They're closer to cars, but they're not like cars either. They don't just run. You have to really know what you're doing in order to pull that out. So these 5 data management practice areas form the basis of our data management pyramid, and I liken it to Maslow's hierarchy of needs. Everywhere I go, people are sort of familiar with Maslow, which simply says that you have to have food and clothing, shelter needs met before you're going to be able to sit down and do self-actualization things. Again, you're not going to write the great American novel if your stomach is rumbling on that. So most everybody, when they think of data, they think of the things that are in this green triangle up there. Big data, clouds, I mean, you just name whatever the silver bullets are. These can be done. But if you do them without providing a good, solid basis for it, it will take you longer, cost more, and deliver less than if you had done them properly by learning the basics. So with that as our basics, then, there is a body of knowledge out there. This is called the Data Management Body of Knowledge, and the organization that I'm the president of, Data International, is responsible for putting this body of knowledge together, just the same way as many of you may remember Project Management Institute put together a project management book of knowledge, and now we have a SWEBOC, software engineering body of knowledge. So we're starting to formalize the discipline, formalize the areas of study around it, and we now have a certification that people can obtain, the Certified Data Management Professional Certification. There are about 1,000 people worldwide that have passed this exam, and the interesting thing is we're starting to see places, including the federal government, that are saying, hey, CDMP is preferred. So if we can get organizations to say CDMP preferred, we now have a capability and objective measure as to whether somebody has the knowledge, skills, and abilities that they will need in order to do this. So that's our data management basics. Just a very brief review of our part 1. Many people did modeling for the sake of modeling, thinking that modeling was the end, and that's not. The key there is that you're trying to attain a shared understanding between IT and business of what the various problems are. So we talked a little bit about how data sharing and exchange is highly automated, which means that what happens in the long run if you make a mistake is that the mistake gets compounded much faster and more quickly, and the messes get very, very big very, very quickly. We understand also that the modeling characteristics change over the course of the analysis, and when they change, this changes the types of things that we put in place. For example, we're going to incorporate purpose statements instead of definitions. It's a small change. But if I say, what's the definition of that thing, you might say, well, it's a bed. And people say, okay, that's nice, it's a bed. If I say it's a bed for the purpose of putting a patient in it, now you have some context that says, oh, no, it's a hospital bed that we're talking about. And the reason we're doing it is because that's how hospitals make money, by putting people in bed. Hopefully they get them out of bed. Move them on there as well. Using the modeling techniques in general, and there are a variety of different modeling techniques that we can look at, pick any one of them and work with it, because we find that the selection of a modeling method and an architecture method is much more important than the actual specific selection. You get down to sort of arguing over nits and gnats, and that's really not going to get you there. So the most important variable is the assumption that you're going to start doing this in a modeling context. These models are living documents. They're going to change and evolve depending on where you are in the life cycle. Your modeling needs are going to change, and so you can use these models instead of as a straight-through process, as a small diagnostic piece to help reach understanding in a certain aspect of the problem solving. The models are going to have modern access and interface and search technologies. In the old days, we could only do keyword search, which meant if I was looking for customer, I might actually find customer. But if I was looking for customer and the organization happened to call it guest and member, I wouldn't get those associations as well, and that becomes more difficult for it. And finally, the key for it is using is the utility of it. And I'll tell a brief little story here because this happened on the George Mason campus. We unveiled the DoD data model here at George Mason, I think it was 1993. And in the process of doing that, I can remember one of the things we ended up doing, instead of showing a highly complex wiring chart diagram like that blue one that I showed you a while ago, we actually had put some clip art on it. Because when we showed this to generals, the generals would say, well, I don't understand what those boxes and lines mean, but if we put a boat part of it, they would go, okay, that's Navy, I don't have to worry about that, and there's a plane over there, that's the Air Force. The key is that if they don't understand the utility of the model, they're not going to understand how it can help them in their business. So that's our brief review of part one. As Eileen mentioned, it's online and you guys can download it and take a look at it. Let's dive into data architecture management. And this is our overall summary of the DIMBOK component here. Again, think of this as an IPO model, inputs on the right-hand side, activities in the middle, and outputs on the left-hand side of the diagram. We're going to cover much of this material here. There's a lot more. Again, you can buy a copy of the DIMBOK if you want. But one of the more important places to start is that when we talk about levels of abstraction, we took the model that we had last time and we went down into the details of the model and looked at the details. Now we're going to come up from those models and we're actually going to be at a much higher level. And so we're going to be talking about these model components. And what I'm showing you here is that when an architect does this as well, they don't design every door for your house. They go around and say, what doors can I have? Can I grab this door? Can I grab these types of doors? Because they're bigger doors and they'll let an accessible needs person be able to get in and out of the building faster. They don't start by handcrafting each of these components. And yet when we go out in IT and build these things, we see this happening over and over again where people are rebuilding basic components like doors and windows. We don't want that to happen. And also in building, it's governed by a governance framework. Building codes, different types of things are put in place. The foundation is going to be something that's going to be inspected before we do it. All of these things are important and will typically show up as what we're doing without having to dive into this a lot level. So again, architecture is this process of designing both the product and process planning, and it's a bad label because it means the practice of it as well as the thing that we produce as we practice it. That would be like calling our teeth dentists, right, or dentistry. In IT, we're really good about mislabeling things incorrectly. So what we're trying to do with architectures, though, is to get to a symbolic representation of the structure, because that allows us to get use and reuse of these resources. When we have doors, and again, doors are kind of easy because people know what they are, but you may not understand what a flying buttress is. Well, a buttress is something that you put for a vaulted ceiling that goes in place. What we're trying to get to is that same shared understanding that the architect and the engineers, when they're building something, have as they're doing this as well. And this understanding is absolutely key because it's documented as a series of blueprints. Now, most IT projects don't have these blueprints, but I can guarantee you that if I decided I was going to cut down that wall right over there, I would need a blueprint, because if I stuck my chainsaw through the wall, I might run into an electrical connection, a plumbing connection, or something else unpleasant that doesn't really match the chainsaw in there. The idea is to have it shared by humans as well as by systems. And the more we can make that shareable, the easier it is for us to manage the various types of architectures that we use. Now, most organizations don't manage architectures well, but the ones that do tend to focus in on a couple different types. Process architecture has to do with your business processes. Systems have to do with the way your systems are arranged. Your business architecture can talk about this part of the organization raises revenue for this part. Again, everybody knows and understands the role of the components and how the components interact. Your security architecture makes sure people who should get to stuff get to it, and people who shouldn't get to stuff can't get to it. We have a technical architecture which says we're going to be a Microsoft Windows shop, and we're going to do it all in C# or Java or whatever it is. And I've heard this referred to as a tarchitecture too. I don't know if that term's actually catching on. It may be a DC only thing. What we're of course talking about today is the data and information architecture. And just in exactly the same way, if we're trying to do all kinds of interesting things with our data, we need to have understandable components. If we don't have those components, then we don't know what we're building. And our data and architecture foundations often become about as solid as marshmallow. And marshmallow, as you know, is not a good thing to build your houses out of. So let's turn to a definition of what do we mean by an information architecture. And I'm going to unfortunately pick on a bunch of my friends who have put these very nice definitions together that I really dislike. So again, the underlying information design principles upon which construction is based. Jim, you out there today? Internet says one, that architectures are plans guiding the transformation of strategic organizational information needs into information systems development projects. Where's the value in that, right? Forrester had a definition, says, provide structured description of an enterprise information assets. Okay, so you're going to describe them. Why would I want to describe them? That'd be like walking into the library and there's a book and there's a book and there's a book. Again, doesn't seem to be terribly useful there. A terrific book, by the way, Roger and Elaine Evenden's book on information first. It's a foundational discipline describing the theory, principles, guidelines, standards, conventions, factors for managing information as a resource. It produces drawings, charts, plans, documents, designs, blueprints, templates, helping everybody make effective and efficient, productive use of information of all types. A great definition, but where's the business value in that? Even our DIMBOK has a definition that it could be improved. It's defining the data needs of the enterprise and designing master blueprints to meet those needs. But if the enterprise is working, why do I need the blueprints? So one of the things that's been very interesting is that the rise of the web in the last 20 years has actually called in. Most web designers understand information architecture really well. So this was a great graphic I pulled off of a piece. I've given you the reference below. But it says an information architecture connects people to the content that they're looking for. Now we're starting to get somewhere. So there's an active definition. We like that a lot. Here's my definition of an information architecture. It's a common vocabulary expressing those requirements and ensuring that the data assets are used in support of organizational strategy. After all, if you don't have a strategy, any road will take you there, and consequently it doesn't make quite as much difference. Now, one of the interesting pieces is that our organization, Data Blueprint, often gets hired to come in, and they say, we want you to develop an information architecture. And I say to them, actually, you have an information architecture, just as this building that we're in has an architecture. The problem is it's not well known. And if you don't know what it is, you certainly can't make use of it. So most often we come in and expose the existing architecture and tell them, these are the things that you have that are assets. These are the kinds of things that we're talking about. This is the vocabulary that we should use here in the organization. And here's a very quick example from an oil company, which, as you might imagine, might want to keep track of different types of tanks, because tanks are things that their products end up in. So here's one type of tank for petrol. There's another type of tank. Again, it gives you a good example of that. Well, there's a different tank. Now we've got, by the way, this is not Shell Oil Company. Somebody said, you got a bunch of Shell examples. Is it Shell that you did that for? Here, again, is a different type of tank. And it's really clear that we need to be sure which type of tank that we're looking at. By the way, there are tanks that float and tanks that fly. So we have lots of different types of variety of these things, and it's important to understand that we should put certain things in certain types of tanks and certain things shouldn't go in other types of tanks in order to do that. And this actually takes us to our first business example, which is we want to make sure we don't get confused with those types of tanks as well. So, again, different things. There's a guy who's tanked, by the way, so we'll just finish that example up. Now, here's the business example, though, and this one was one that we did right here in Washington, D.C. for a group of the member of the Armed Forces, a branch of the Armed Forces, excuse me. When you buy a tank, and now I'm talking a different type of tank, of course, it actually translates into 3 million unique data values. Now, you might say, well, do I need to keep track of all those data values? And it turns out the answer is some are more important than others, but the one that controls the obsolescence of that particular tank might be an important piece. For example, if I don't know which one of those 3 million data values controls obsolescence and I treat all of them equally, which means generally very poorly, I may have tanks that I don't want to maintain, that still I'm spending money maintaining them. I'm warehousing them. In fact, the case on this one was about $1.5 billion in savings for a group of the armed forces here. So that's a lot of money when you start to talk billions. And let's look at what happened here. They were generating all kinds of unnecessary cost and impacting operations very, very poorly. For example, storing the tanks, handling the tanks, picking them out and running them, driving them around the block once a week to see if they work, right? Oiling them. Again, if I've got tanks that I'm holding that I don't need anymore, I can sell them off to an ally and somebody else can do something with them. I may not understand the electronic needs, the systemic needs that are in there. Not only every tank, but every tank comes with 3 million values, which is, a good server's worth of stuff. And finally, we're maintaining items that we should really be selling off and getting rid of. So here's $1.5 billion of business value to one of the branches of the armed forces just on doing a little bit better management of their information architecture. And the architectural component is I've got 3 million individual data items, but some of them are more equal than others. And we want to keep track of those because when something expires, I want to get rid of it, move it off my books, and move it to someplace else so that somebody else can have the pleasure of maintaining old, used stuff. So our next section that we dive into is architecture and modeling, really what we're trying to do and say, why is this stuff important? And we can ask all sorts of questions. We've already used the building analogy. Would you build a house without a sketch? The answer is clearly no. Would you give somebody a check to write if they hadn't at least showed you what the thing looks like? Even Amazon gives you a picture of the product that you buy before you go off and do it. If you had a bunch of contractors that were going to come build it, would you say, just build me a house over there that's got 4 bedrooms on it? They'll be happy to do it for you, but, again, it's not where you're going to come to some understanding. How do you verify the proposals that are in place? If it's a really great house, maybe you'd like to build it over again for somebody else, sisters, in-laws, something like that, or something in a similar vein. Without those plans, you can't recreate it. And again, we've already talked about taking a chainsaw into the walls and not knowing where the plumbing, the electricity, and things like that are. So all of these are critically important, and yet if you look at the architecture of most of our IT projects, it ends up looking somewhat like this description here, where we've got really clever IT people, and they absolutely could add another layer on top of this house. But if you really knew what this was, would you feel comfortable basing, life and death decisions on something like that? And the answer is maybe yes, because this house happens to actually have a pretty good foundation, whereas this house, hopefully you all agree, we would not put any more money into this vehicle at all. It's not going to work with us. And, of course, management thinks they're getting one of these. So as we work our way through here now, we have a couple of polling questions, and we wanted to ask you guys these questions as well. So our first polling question here is, do you believe, from your own perspective, that your organization has a solid data architectural foundation on which to build their IT projects? Just give us a yes and no. And we've got another question that's going to come right up after that we're going to ask you as well. So Shannon, I'll let you pop those up. You should see it actually, Randy. Maybe. Oh, you can vote. There you go.
Sorry, I was fumbling with my mouse there. Yep. So we're going and people are voting.
Stay close because we've got 2 questions for you.
Yep. We've got, looks like about 2/3 are saying B.
Interesting. So the answer I'm getting in my headpiece is about 2/3 of the responses are coming in with B.
Yeah.
That's actually good for you guys. They need information architects.
All right.
And tell me one that we put to this. All right, do that one. And then our next question that we have out there, actually we should display the results, right?
Yeah, let me close the poll here. Mm-hmm. It's about, so about 2/3, let me open the, polling results here. About 2/3 say B, so 55 said B and 28 said A.
What is the third choice?
Or no answer is the third choice.
No answer. Okay, there we go.
So there's the results.
Question. Go ahead, Shannon.
Yep, okay.
Do you think your organization is capable of building this? So again, first question was, are they doing it? Do they have that foundation? The second question, does your organization have the requisite knowledge, skills, and abilities to put something like that in place? Again, we'll just leave that open for a quick second or so and see what we get in the way of responses there. We actually use these to figure out which seminars we should run for you guys next, so if you need more or less of these topics, et cetera, et cetera.
And looks like the majority is currently answering A.
Okay, so here we have untapped potential. If most people say they can do it, but they're not ready to do it, they need some leadership in this case to help them unlock that value, unlock that business value that they have.
So let me close the poll here and share the results. So you can see the results there. So 60 said yes and 21 said no.
Okay. Thank you, Shannon.
Mm-hmm.
So let's move on a little bit. Some of the architectural components that you have are interestingly enough, have actually disappeared from university education. And what I'm showing you here is a context diagram that used to be part of every systems development project that we'd start. And you can look here, and all we're doing is we're showing the major actors that are involved in this, and we're talking about things that are internal to the system. So we're saying that the online community in that circle is the boundaries of our system, and things that are external to those boundaries are not part of this. This is one of the most important tools that you can have to prevent what we call scope creep, which is one of the things that most of the IT projects suffer from as they go on, because people don't know whether something is part of it or not. But if I put a little logo up there, does anybody recognize that logo? You may or may not recognize it. That's the Internal Revenue Service. Are they likely to be part of our context diagram? Yes, they'll be on the outside because our chances of influencing the Internal Revenue Service are slim to none. Not that they are bad or good people. In fact, the keynote speaker at our conference we have coming up at the end of April is from the Internal Revenue. Terry McAuliffe is going to be one of the keynotes there. So we're really looking forward to it. And good news and bad news. It's really wonderful that a government agency is becoming very competent in managing their data. It's just too bad that the Internal Revenue Service is the one that's doing it, right? Terry likes that particular piece. Here's another architectural diagram, though, that just simply shows too much. This is a wiring head diagram. There's nothing that a business person can see in this diagram that is going to be helpful to them. I can tell you for a fact that if we had unveiled the DoD data model here at George Mason 20 years ago with this type of a piece on it, the executive that was in charge of it would have simply had our heads. Too much detail. You've got to target your architectural pieces for the appropriate audience. A person who reads the electrical diagrams is not going to understand perhaps the plumbing, and they're not going to understand the human traffic, the workflow interface pieces. I mentioned before the web developers tend to understand this. Here's just an architecture from a guy named Jeff Kern, who I thought had a really nice picture. When you look at something like this, and again, I know it's very readable on the screens that you're seeing there, but you can get a really good picture of where this IT architecture is depth in terms of the information. The blue area shows it goes down one way, and the green area shows a lot of different other types of content. I don't even know what type of website this is, but you can get a sense for yellow is going to have a certain impact, green is going to have a certain impact, blue is going to be a very definite piece. Probably the purple on the left-hand side is some sort of housekeeping. Again, we could go on and look at that. And actually, Jeff put another piece up here, which I thought was very interesting. He calls information architecture part of the user experience, and I like that. Again, so everything in pink there, he's saying, look, this is part of what we do to make sure that people get connected to the content that they're trying to do. So as we look at what information architecture does, this is how we try to put it in place. The real challenge for all of this is, of course, we're always building in response to immediate needs that are focused on local optimization. So while I may have some software programs and I may decide that I need that brown database that I'm showing on the diagram there to service those three programs, that sounds like a really nice way to do it. I can have one data store and three programs that all get to it. It's probably more efficient if I do a good job of doing that. And the question comes up then, here's another group doing exactly the same thing. Now, if they are doing the same thing and they don't know they're doing the same thing, then the blue and the green should really be one. I said blue and green, brown and green. The brown and green should really be one database, and all of them should be connected. But, of course, what happens is, well, brown is not quite the same as green, so we want to make it different. What we see here is that there's usually 80% overlap in many cases between the two of those. And it's not that you should keep them separate or different, but if you don't have the information, how are you even going to approach the decision? People don't know this. They don't know to go looking for these things. Again, we put an orange one up here. Is the orange one closer to the brown one or closer to the green one? Or should we have one big brown one and cover all of them in that way? If we do this right, then we have the ability to focus all the way throughout the organization on this. It's a much broader focus than just software architecture or database architecture. So data architecture, pervasive. It means that when we're looking at things like big data, we know where to fit it in to our larger picture. It tells us that the analysis is on the entire use of the system rather than on just a small fraction of it, that the problems are usually end up occurring because we have exchange problems between the blue and the green or the brown and the blue or whatever it is. And, of course, this really talks to strategic goals rather than operational goals as we move into there. Now, last time I did this, I asked the question, did anybody remember the term 42? And it's not that you would necessarily remember, but the fact 42 is my age 12 years ago, which who cares, or it's the meaning of life. Well, you learned something new in school today. Right? I've got a couple people in the room who've read The Hitchhiker's Guide to the Galaxy as well. What I'm doing, of course, by doing this is simply saying that if we have the facts out of context, they mean absolutely nothing. But even facts and meaning and data as a structure, we now need to impose that information architecture layer on the next piece of it. And what we really want to do is get to that intelligence layer that's at the top of this thing. And it's out very well, but most of the time, as I said, the data and information layer are very poorly managed, and that's why data warehousing has a 50% failure rate. I don't know about you guys, but if my dentist said I've got a 50% chance of pulling your tooth out and a 50% chance of shooting you in the foot, I'd probably go find a different dentist. It just does not make sense. These data structures then are expressed as architectures by organizing details into larger components. The larger components, we organize them into models, and we take the models then and organize the various models into architectures. I'm not sure who's got a T-shirt there with data structures on it, but we're in a computer science school at some point, so we can do that. But that gives us the ability to do something like this, where I can connect conceptually a shipping network with the chemical industry, and this was a project we did a couple of years back, with the financial services industry. And the idea was when the chemical industry sold a product, so a bunch of oxygen or whatever it is they're making chemically, into something, they could immediately hand the tracking information off to the shipping network so that whatever customer would be getting it down the road, and they could sell their inventory, their accounts receivable off to the financial services network and bring the cash in immediately instead of waiting 30, 90 days to collect it. Actually, you guys have seen that some of the bigger companies are actually going out to 180 days payable, so it's a half a year before you get your money on some of those instances. So from a data perspective, we have entities that are made up of attributes, and these are business things about which we create, read, update, and delete information, and we manage those. And there's a lot of examples. Customer would be a main one that we tend to talk about in there. Those attributes are organized into models. So again, we have attributes, entities organized into models, and we have examples. I'm giving you a couple of examples already. Just the model of an information architecture back there a couple slides ago is one of those. But when we take models and organize them into architecture, it gets a little bit more difficult. So oftentimes with an architecture, you're going to have layers. It's very difficult to show a whole series of layers that you have in this context. So it's very difficult to show examples. That's why people don't have it. But if you think about it in the building context, the architect's going to be walking in the building, picking up these pieces of paper, flipping through them, and trying to find which piece has which set of factual information so that they know when they drill into that wall, they will not hit electricity. This ends up being highly useful if you ask the question, how do these data structure arrangements support strategy? The easiest way to answer that question is to reverse the question. If they weren't explicitly designed to work together, what are the chances that they are going to work together? And the answer is, unless you have a very lucky set of coincidences, absolutely not. Your organizations are spending between 20 to 40% of their IT budgets on messing with this type of useless, non-value-added maintenance. And that's a lot of money. Recently been with an organization that's spending somewhere upwards of $4 billion a year on IT. Well, that adds up to $1.5 billion minimum that these guys are going to be able to save. And the example that I like to use is if I was running a restaurant and I had really fancy dishes for all, and when I say dishes, there's another example, right? Is the dish or is the dish the thing that's on the dish? But if I had really fancy dishes and things, that I broke a dish on the way to delivering it to a customer, I'd have to go back to the closet and find the proper dish to put that thing on, right? Because we want presentation to be an important part of that sort of thing. If I used standard dishes, then I could grab the next dish off and put it down. Now, that's not going to work for every restaurant, is it? Some of the restaurants, it's very important that you have that dish be part of the presentation. Other restaurants, depending on the strategy, any old dish will do and they can grab the next one. So if you don't have that planning, you will end up haphazard, like the one that's on the top there. Again, two types of goals, efficiency and effectiveness goals from one perspective and providing dexterity for the organization. Oh my gosh, we have a lot of egg dishes, and all of a sudden they discover that eggs are more dangerous to us as people than cigarettes are. Have you heard that one yet? Yes. There's a little theory out there that says eggs are almost as dangerous as cigarettes. Okay. Well, we have to change our menu suddenly, and this top set of dishes is not going to work. But if I'm in a standardized environment over here, it can be better. Again, these are not panaceas. They don't help with all of the questions that you have, but architectures tell you how and why the various components interact with each other. Where should they be placed conceptually as well as physically? Again, we're on the George Mason campus here in Fairfax. If we were someplace else trying to teach class, I don't know if you guys have done much distance education, but we've had all kinds of experiments with it. Sometimes it goes really well, sometimes it doesn't go. When do they need it? Again, talks about timing. How will the changes be implemented when I roll it out? Is it going to be campus-wide, or am I going to just do it at one part? Which parts of the organization should be managed globally? Which parts of the organization should be managed locally? As you might imagine, here at Mason, we have different rules for the School of the Arts than we do for the School of Engineering, and that's entirely appropriate. What standards should we adopt? What vendors should we pick? Again, it's just some of the questions that you look at. What rules should govern those decisions? How experienced, who has the requisite knowledge, skills, and abilities to, in fact, make a decision along those lines? And what policies guide the processes overall? These are just some of the things that an information architecture provides. Now, the way we think of it is, at the most generic level, we have organizational needs. Now, remember, most organizations aren't aware they already have an information architecture, but that those needs have been expressed and are instantiated into this data and information architecture. And once you have that architecture, that then authorizes and articulates the requirements for your systems. If you have those requirements, then all I need is a feedback loop to say, how's it going? And the problem is many people say, okay, well, you satisfied my specific information needs, we must be done. And, of course, I hope you agree it's a continuous process, because unless your organization is going to stop dead in the water, there's absolutely no chance that you'll be able to move forward with an architecture that flexes, that adapts to your needs, that changes. And here, again, we were just talking before we got started here at the session. This school, when I went to it, had a bunch of trailers around. They really called it Trailer Park City at one point in time. Randy and I have both been students here at one point or another, as well as faculty. And it's amazing to see the way the campus has grown. It's clearly not the same place as it was, and if we tried to do it with the same infrastructure, it wouldn't work. So that leads us to our next series of polling questions. We've got 2 more of them in here for you. And we're just interested in you guys telling us, is your organization using enterprise data modeling to achieve integration? I mean that at the high level, in the sense that you're trying to put an organizational level data model that covers more than just an application or more than just a subject matter area in there. So we'll let Shannon pull the poll up there and take a look at it.
Hi, I'm just getting it up here. I thought we just asked that. Let me open the poll here. So it looks like we're about 50-50 as people are answering.
Okay.
We've got a strong, we have 36 saying yes and 36 saying no.
Okay, no problem. We'll move on to our next question then.
Let me close the poll here.
And the question here is, what should your organization be doing? So what's your belief on whether an organization should be implementing these types of technologies?
Sorry, it takes WebEx a moment to
reset itself, right?
Yes. There's the results from the first one.
So 50-50? Okay, good.
Yeah. Let me just...
Shannon, I keep trying to play the Jeopardy Think music in here, and I can't quite get my iPhone to do that when we have it all conferenced up.
I need to work with WebEx.
I think if we do play it, we owe Murph Griffith's data like the money or something, you know. Wouldn't want to get your hot water that way.
Let me open it up there. Sorry, I need to talk to WebEx about making it a little less encumbersome. we got a strong yes on
okay.
that.
But like 90% or something?
Yeah. 69 saying yes,
Andy?
4 saying no, 71.
All right.
Yeah.
So 2/3, 70%.
Yeah.
Great. Well, again, you guys, this is helpful to us just in terms of working on it. Plus, we've actually got some follow-up hubs we're going to put out on Dataversity as well to give you guys some summary of this information as well. All right, we're ready to move on, Shannon?
Oh, yes. Did we not? I cleared the poll. Sorry. I showed it there for a moment.
She's still showing the polling question on the question. I hope we don't end up with that. I wonder if that's a bug in WebEx.
Yeah, let me clear it.
Eileen, are you seeing screens change?
Yes.
You are? Okay, good, because we're not seeing it on this end. But tell you what, I'll stop it real quick, restart it. So what this is about is leverage, and what we're trying to get to, hang on, let me just stop that and restart it. There we go. Okay. Leverage is an engineering concept, and it's not typically taught in business school, and it's not really taught as part of data management either. So leverage permits organizations to get the most out of their assets. You talk about leveraging financial assets. Everybody understands that's what a mortgage is. You don't have enough money to buy a house up front, but you can pay for it over time and get you that way. Data leverage is exactly the same thing. So what we're trying to do, and I love this particular phrase, is their most powerful yet underutilized, poorly managed, durable asset. So if you talk about that in financial terms, all of a sudden the CFO starts paying attention to these things. This is both within the system and, of course, across our organizational data partners. The idea there is that we're trying to set up data-centric technologies, processes, and human skill sets, and we need all three of those: people, process, and technologies in there. The goal of leverage is to eliminate data rot. Rot stands for redundant, obsolete, or trivial data. And if you think about it, for most organizations, the standard Pareto analysis applies. 80% of their data is just absolutely useless. It's redundant, obsolete, or trivial, which means when you're trying to find something, you don't know which copy of it you should be using. Where do I go find it? With big data, the problems get even more involved on this. So leverage is obtained by the elimination of rot, and it's a very simple engineering equation. The more that you put into it, it lowers IT costs, and it also improves the productivity of your knowledge workers. One of the other case studies we talk about has a direct implication on curing cancer because we're able to improve the productivity of cancer researchers instead of making them SQL people who, while SQL is fun, it's probably not the best use for cancer researchers doing that sort of thing. And in all of these cases, we can define the area that we're talking about, the architectural evolution, to some set of predefined constructs. It's a very nice formalism that says our models are evolving from as is and to be, from conceptual, logical, or physical areas. And then we add one more component in there, whether they are validated or not. If they're not validated, they're not quite as useful to us. So we can take a architectural component, I'm showing it in purple there, being a physical as-is model, migrate it into that orange piece, which now takes us to the logical as-is, move it down to the brown area, which is a logical to-be, into the yellow area, which is our physical to-be, and then finally we want it to be validated. So that's the goal of trying to take most of these components. When you look at how systems are re-engineered, we end up not following this formal process much more than we should. And even though we teach it to all sorts of good computer science and engineering students and business students, the rest of IT doesn't understand this. And when they don't do it, they just try to move directly from the purple to the green. And that's where most of these things fail. Another important component of architecture, too, is that we're really talking about application-centric development and changing that paradigm. In application-centric development, an organization starts out with strategy, moves to goals and objectives, and a very natural process is to take it the next step and put in systems and applications. After all, you would think, I've got IT systems, I should put them in place. Then you put in network and infrastructure, and that, okay, makes fine sense. But data and information is always the last thing that's considered in that process. And this guarantees that the data is formed around the application. It means that the process architecture also is narrowly formed around the application. You have very little, if any, data reuse that is possible. I have to stop here at this point and say that when we look out across the goal of object orientation, which is what we've all been plugging away at for the past 20 years, very little software is actually reused either, beyond the open source type of community, but the actual object orientation has not provided the reuse pieces that we've looked for. So when we change the paradigm slightly and say, no, let's talk about it from a data-centric perspective, we've got the same two top levels. Organizations have strategy, they need some goals and objectives, but if we next define the information layer, then the systems design for whatever systems we put in place simply becomes a matter of taking data from that information layer and delivering it to customers at various places. If we're able to maintain that in a large context, it means we have a much different focus for what we're trying to do. If I buy SAP, for example, as step 3 of the previous slide, I've now got to have a big SAP network and all sorts of SAP experts to bring into place. And we talk about SAP instead of talking about delivering business value on this. This makes sure that the data and information assets are formed around organization-wide needs, not application-specific needs, that the systems support and complement the organizational flows of information instead of the systems flows, and that we can finally reuse and maximize our data in this context. So data architecture is really poorly understood, and we have to take our shared blame for that here in the academic community. It's also pretty inarticulately explained. We don't have very good books that describe this. There's some that are out there. We're trying to get better with it. And it's indirectly experienced. Everybody just, hey, you've got an IT problem, and it's about as close as people can get to it. So it costs lots and lots of money, and again, ends up being poorly thought out software purchases. So if I go and buy SAP to solve a problem, it may be the wrong investment, particularly when you consider the fact that when you buy an ERP, things are going to get worse for your organization for a total of 6 years before they get better. Well, that's a long time and a lot of work to do. And what we want you to think of instead is picturing these architectural work products. I'm going to run through a couple of them really quickly. These are just some examples. It might be a couple of PeopleSoft modules. It might be a different data structure here, and I'll show you some examples. These are just some engineering components that we would not go out and buy. You don't want the guy that's going to build your house to build your refrigerator, right? I mean, come on. We've got that part down. We've got the stairs down. We've got the building blocks in place. We know how to do this. So here's some examples of architectural components where we're describing system 1 here as 3 processes, and process 1 is clearly more involved than process 2 and process 3. Again, we don't know what it is. We're doing at a very abstract level of it. Or here's a different type of decomposition that just shows how one branch of the military organizes its pay and personnel information on it. There's another one that shows a little bit more detail. Here's some interesting ones. So this is actually the state of Virginia's Department of Social Services strategic data model from a couple of years ago. And in the past, we would have said we have to have the whole model before we understand it, but we can now break it down through something called clustering analysis that tells us which are the important pieces that have to cohere, and then there's other pieces that don't have to be coherent. So we can look at the taxpayer view and work just in there, a client view, right, a governance view, in this case a program delivery view, or a vendor view. Each of those are equally valid as we do it, and not until we put them all together do we get the whole picture of it, but we don't have to have the whole picture before we can deliver value. And this is really the key to this, is to be able to look at these things. So our last polling question here for the day, and then we'll move into some examples, is we just want you to tell us your organization uses what approach to achieve organizational integration. Is it A, organizational data modeling, B, point-to-point interconnectivity, where you're creating lots of interfaces, and by the way, each interface is a separate IT system on its own, so now it has to be maintained, or are you distributing your systems implementation, or is your organization sort of kind of flying by the seat of its pants, which is the D question. So Shannon, let's put that up there for a minute or so and see what everybody comes up with.
All righty, just getting through WebEx here. Let me
Do I detect some frustration with WebEx there, Shannon?
Just with the polling.
Yeah, really, the product's been great for us. We've actually had a really good experience with it. We're still getting to learn how to use it.
All right, let me open the poll here. Let's see. Here we go. And it looks like we've got the Good variety of answers going on here.
Good. Well,
tough to say which one's ahead of the game.
Mm-hmm.
Pretty even distribution. And let me go ahead and close the poll here and share the results. It's closing. It looks like we got, a pretty good even distribution. 19 said A, okay. 19 said B, 6 said C, and 17 said D.
Okay. Well, again, thank you guys for paying attention to that. It's always kind of fun to get you part of the picture. And as I said, we use this information to help put some more reference materials for you guys together. So about 10 minutes left here. Let's work through a couple of examples, 3 examples in particular, of how we used architectural components to solve specific business problems without going to the big data architecture in the sky thing that we did. So just to set the context for you here, we're taking an old green screen application and we're moving it into a new, more modern environment. We're going to put PeopleSoft in place, so it's another ERP implementation. There are major changes to the operational processes. One of the measures that we used to describe the magnitude of the change was on the old system, all the information was on one screen, but in the new system, the information that you need to service financial needs is on 23 separate screens. Well, that's going to imply some changes to workflow, I hope. You just certainly don't want one person to sit there and understand all those 23 screens. That's a lot. And management was kind of worried about the workflow having to change those series of changes to something else, which was that the basic change in the organization was that they were moving from dealing with Social Security number as an identifier into some sort of good generic ID on this. And they said, well, how much would it be to reverse that change, to go back to Social Security number? Now, you guys here in the room are laughing. That's great. You passed the test on that one because, of course, clearly that is the wrong answer. But nevertheless, from the big consulting company, they got the answer, oh, it's not a very big change. Well, let's just take a look at how that works. First of all, in order to look at PeopleSoft, one of the things we did is reverse engineer it. So we understand that PeopleSoft has a process architecture structure, talking about the homepage names that are related to the business process names, and each of those are related to business process components. And again, each of those are related to business process component step names. So everybody that's watching this now understands the process metadata for PeopleSoft. By being able to do this, you've got a whole lot of knowledge about what PeopleSoft actually arranges itself as. So when we do a query into the PeopleSoft internals, we end up being able to look and say, hey, business process name called Administer Base Benefits has 4 components. First one's called Manage Benefits Enrollments. You can see the rest of them there, and each of them has multiple steps. Clearly, managing benefit enrollments is more complex than managing benefit dependents in orange or the teal managing leave accruals. And you would assume that anyway, but it's nice to have factual information to tell you about that. When I get that, I can do this sort of a meta model of what PeopleSoft metadata structure looks like, and I can map back onto it. I've circled the home pages up there. There were 7 of them, 39 business processes, 180 process components, and various process component step names. I've also got on here panels, menu items, screens, all the other things that we'd like to see. In other words, if I'm going to have to change things, how many things am I going to have to change? And when I do that, I can now look at business value and say, what are the things that when I change are going to cost me money? So 1,400 panels, 1,500 tables, process component steps. We'll put a measure of 15 minutes per change on there and see if that works. So that's almost 1,000 of them, and if we multiply it at a decent consulting rate of $200 an hour, it's $200,000. Although luckily the state of Virginia, I don't know if you guys are taxpayers here or not, but I sure am. When they do this, they make you forecast the change out for the next 5 versions of the software because they know that when they change the software, all these changes have to be reapplied. So we add that to 5 upgrades, and now you've got $1 million decision. That's very different from not much. So having the architecture here allowed management to make a good decision here, whereas before, not much, it sounded like it would be an okay decision. Again, we look at these things and say, by the way, 15 minutes is probably the wrong number too, isn't it? So double it and we're at $2 million. Okay, now we start to get somewhere. Let's look now at a donation processing center. This is a cancer institute that is, again, doing things like helping all of our relatives, avoid and be cured of terrible diseases. So they've got 500 researchers down there. These are very expensive people. And when they want to know something along the lines of, do I have 300 ear cancer patients that I can run a study on? I don't know if your ear cancer is a real cancer, but if we do, these researchers would go to these files and start looking through them. That's clearly not the highest and best use for people who are brilliant in solving cancer. So it required a robust data management system that they just simply didn't have. And just to answer that question would often take them a month of somebody's time. Now, they had to do it for two reasons. One, they wanted to solve ear cancer, but also if the National Institute for Cancer said, I've got a grant money, thing that I can do that, we can go back and do that particular piece as well. So huge needs on this. And when we look at the current architecture that they had, again, I don't expect you to follow this through, but you can see it's a very complicated process where we had to pull from multiple different data sources and integrate from a number of different perspectives information that had never been integrated, although information that was clearly integratable. So our before model looked like this, and our after model, so there's one place that you can go and do this, and more importantly, instead of having all the cancer researchers go through and do this, we can train a good data management expert, big data person who can come in and run those queries for them without having to bother the docs who do have other things to do. Now, the payoff on this is amazing because when you look at this, these modelers, these subject matter experts are very expensive, and if they're spending 80% of their time searching for information and 20% of the time acting on it, which is a typical ratio, all I need to do is to move down this little curve a bit from 1, where I have up there, to 2, and I've doubled their productivity. If I could actually move it all the way on down and get them to just 20% of their time doing non-value-added stuff, we're talking about a 75% improvement in the productivity that we have through the use of an information architecture. Who would have thunk it? One last example before we get to your questions. This one is, again, emphasizing the importance of understanding the relationship between architecture and engineering. Again, architects create great ideas, but we need engineers to implement them. Engineers tend to like to have architects to give them the vision in order to do this. So I show this picture, and I ask groups when I'm talking to them, what is it? And they kind of look at it and go, it looks like a mixer. And I say, well, it's got some particular attributes that are interesting. For example, it's taller than I am, which isn't saying much, but it's a pretty big instrument. It has a clutch. It's built in 1942, and it still works today. And you say, what on earth could this thing be, right? Well, it's the way you make pancakes for thousands of sailors who are on the USS Midway. And they're out in the middle of the ocean, and they're hungry, and they need to be fed. And somebody says, well, couldn't you just buy a bunch of these things from Amazon? Yeah, after we make the 3rd, 4th, 50th day of 2,000 sailor breakfast, those motors are going to burn out, whereas this motor is still running today. They still use this. Now, the engineering concepts on this from the data architecture perspective are something we talk about normally as a data mining context in here. So what we're trying to do is get the architecture from an existing series of systems. And this is an example from the Defense Logistics Agency, where they were doing a system migration, and their data was in what we'd call a non-tabular format. We needed to move it into a tabular format so that we could have a robust architecture. Unfortunately, however, most of it gets referred to as unstructured versus structured data. We don't like those particular terms. So again, we developed this data mining algorithm in here, and this was really fun because this was the first time I'd ever saved a person's century of work. Now, from an engineering perspective, you've heard of a person year of work or a person month or a person week. This is a person century. What you're trying to do is identify the point of diminishing return. So when we did our mining, we knew we weren't going to get everything. But as we pulled the information out, you can see here, week 1 we started out and we didn't match 31%, and we didn't really change that much. It kind of went down a little bit at weeks 2 and 3, but it was kind of problematic all the way around. On the other hand, the number of things we could ignore, exclude, there's nothing in here at all, go away, was up to 12%. And the things we matched were 55%. So at 4 weeks, we had actually solved 2/3 of the problem. Now the question was, how far should we go? And the answer was, you go to the point of diminishing returns. Well, where is that? Well, it's easily identifiable. If you look down here, we got up to 68% by week 14. And the only reason we went a little bit beyond week 14 was because it started to dip a little bit and then come back up. So we eventually matched 70% of them. We eventually found that we were able to ignore 22% of them, and the original problem space went from 2 million unstructured data items down into an information architecture that had 7.5% of the original problem in it, which meant instead of dealing with 2 million SKUs, we were now dealing with just 350,000 of them. And I don't know about you guys, but I'd rather deal with 350,000 on it. So what's the business value of it? Well, again, quantitatively, it was pretty easy. There's 2 million SKUs. We drop in a little bit of metric on them, figure out how long, how much, where it's going to cost. There's my person years, 92.6 person years, a person century, and $5 million. And oh, by the way, again, there's not a chance we're going to do this in 5 minutes, is it? So double it, we're at 10 million, triple it, we're at 15 million. So again, very quickly there, we're at the top of the hour. That's our set of sessions on this. I want to just, before we move into the questions here, talk quickly about takeaways. Again, what is an information architecture? It's this database, not database, but data-based arrangement of organizational assets that we're using. You use that information architecture to solve very specific business problems, and the organization doesn't get it by creating these architectures. You continually reinvent and evolve these architectures. Again, we've got some upcoming webinars, and of course, we're going to talk about the special one that we're excited about. This is actually a conversation that Micheline Casey and I are going to have, where we're going to talk about this top data job picture. But now it's time to stop and let you guys have your questions. So I'll turn the phones back over to Megan.
All right. Thank you, Peter. That was a great presentation. Now it's time for our Q&A. Time for you guys to ask your questions, so just click on the Q&A section. You should be able to submit your questions through that Q&A window. So we've had a few come in. Let's see here. All right, the first question is, I would like to know who is best positioned to sustain or maintain the data architecture.
So that's a great question. Unfortunately, most of what we see is that this function is buried 2, 3, 4 levels down below the CIO. And so they're usually very experienced people. They do it because they love it. I mean, again, I'm sure most of you guys wake up in the morning and go, wow, I really want to be an information architect. But people who are drawn to this field tend to do this. When I stand up in front of a group of, several hundred data managers, and I ask them, where did they come from? Nobody advised them in college and university that doing this would be a good career field. It's something that they decide is internal to them. And the problem is they're always being asked to fit into an existing IT project mentality architecture. So we're trying to do this as a project, and they say, okay, good, we're going to do this. And if you read what we in the academic community have said to do, you build your data and your processes simultaneously as you're going through this. And now we want to do it faster. That's what Agile is all about, right? So now we're doing it faster. We don't even have time to build anything there. So more and more we're seeing a difference between what currently exists, and what should be. And that's actually the subject of some of the things we're going to talk about in this upcoming webinar that we're calling the Top Data Job, or the CDO seminar. So when you say who's responsible for it, ideally the organization should be responsible for management of its assets. Your CFO is responsible for management of the physical architecture of the organization. Your chief medical officer in a hospital is going to be responsible for the healthcare practices and all of these things. But I guarantee you, your CIOs, as smart as they are and as hard as they work, don't have the bandwidth and the attention to be able to do this, and your email and your backup. And by the way, they're also charged with business alignment and implementing a CRM system and managing their offshore capabilities in this. And oh yeah, somebody told us we had to do some cloud stuff this year as well. You need a full-time person dedicated to this. And so that's, again, sort of a little preview of what's coming up in that area. Great question.
All right, and the next question is, how do you separate Biz A from Proc A?
I'm sorry, I don't understand the question.
We'll see if we can get a definition on what they meant on Biz A and Proc A. So we'll move on and see if we get a response from them. How many are willing to pay for an architecture is the next question.
Yeah, so it's really up to us in the data community, isn't it, to talk about the value of this. And that's one of the things that big data has really been good, because at least data is on the radar screen of the boards and the C-level executives. And, oh, by the way, there's a regulatory lever as well. So if you're in the financial community or in the healthcare environment, those regulatory levers are very important. And actually, I'll give you one. I was working for a big retailer not too long ago, and they had an issue where they just had some chemicals that they were moving around, and there were regulations associated with the chemicals, and if they didn't provide certain notification, they had fines, and those fines added up to be a very large amount of money. So while we talk about, nobody really wants to pay for it, there's the carrot and the stick approach. I've just outlined 3 types of sticks. Medical privacy data, different types of security components that are needed to have in place, and again, regulatory or fines and things like that. But the other part of it is that if you do have an architecture, you now have something that you can evolve. If I have to stop and get the blueprints to this building, if I wanted to turn this building into a condo, for whatever reason that might be, I would have to go back, strip down the thing, and figure out where the blueprints were, where things were, in order to figure out how to change it. So organizational dexterity is another huge lever on that. And the question, who pays for that? The boards, right? The boards end up paying an awful lot for that.
Right, great. The next question is, does a model include data fields and terms? And if terms are not included, what is the risk?
Absolutely. Great question. So if somebody shows you a model like I have shown you today without also including the definitions in with it, it is wrong by definition. So good for catching me on that particular one. Yes, the proper architecture is going to have a set of data dictionaries that go with it that define each and every component in there. If you don't have that, then anybody can look at that and say, tank, I know exactly what you mean. And we saw at least 6 different types of tanks that we were talking about in there. Great question.
All right, and the next one is, can you talk a little bit about the role of metadata and where it fits in the making information architecture possible?
That's a great question, too. So Gartner has come up with a definition of metadata that we really like. Metadata is something that adds value to data, and therefore, because it adds value, it must be managed. Good, and needs management attention, I think is the way Gartner actually refers to it. So all of the things that I've shown you in the diagrams today are bits of metadata that we're looking at. It's, again, arrangements, collections, all the things that we pull together, the definitions. So you can see clearly that a metadata management practice is required in order to have an architecture practice. Again, it's one of those things when people say, well, I want the metadata people to do this and the data architecture people to do that. No. Put them together. Get them to work synergistically. I've seen too many organizations where they separate out the warehousing practice or the modeling practice. The more integration, the more synergy that you get here, the better the results you'll get. So I think we've got a topic coming up on metadata, although I sure couldn't tell you when. Maybe Meg, you can look that one up while we do the next question.
All right, and it looks like that is actually all the questions we have for today. So thank you, everyone, for participating in today's event. We hope you have enjoyed it. Thanks again to Dataversity and Shannon for hosting us. Once again, you will receive today's materials within the next 2 business days. Our webinar next month will be unlocking. That's not the next webinar. The next webinar is building the case for a top data job. And so I hope you guys can join us for that one as well. Hopefully, as always, feel free to contact us if you have any questions. Thanks, everyone, and have a great day.